In this topic, we will learn about the virtual reality in product development, revolutionizing design and validation. Virtual reality is revolutionizing the entire product development lifecycle, from initial concepts to final validation. VR technology enables unprecedented collaboration, speed, and cost efficiency throughout the process. Designers and engineers can now work together in immersive virtual environments to ideate, prototype, and validate products. This allows for faster iteration, earlier detection of issues, and reduced physical prototyping costs. The result is a more streamlined and efficient product development process that delivers better outcomes. The legacy challenge in product design has been reliance on 2D CAD screens and physical prototypes, which limit collaboration and delay feedback. Engineers often worked in isolation, with design flaws discovered late in the development cycle. VR technology is revolutionizing product design workflows. It enables immersive interaction with 3D digital models early in the lifecycle, allowing real-time design exploration and iteration across distributed teams. Changes happen instantly, and feedback is immediate. As an industry example, Keysight's IC.IDEO platform replaces physical mock-ups with virtual prototypes, accelerating decision-making and reducing costs by up to 40% while enabling global collaboration. The product development lifecycle is being transformed by the integration of VR technology. VR enables a continuous feedback loop that drives innovation across every stage of the process. In the concept design phase, VR allows for rapid visualization and stakeholder alignment in immersive 3D spaces. During detailed engineering, VR enables real-time collaboration on complex assemblies and spatial relationships. VR-based engineering validation allows for fully functional virtual prototypes to be tested before physical builds. In the production-ready phase, VR is used for manufacturing simulation and assembly sequence optimization. As a case in point, Valve Corporation leveraged VR for iterative prototyping of their VR hardware, which reduced development cycles by over 30% and improved ergonomic outcomes. VR provides true-to-scale 3D spatial understanding that flat screens cannot match. Engineers can experience products as users would. Identifying issues invisible in traditional CAD VR allows dynamic simulation of assembly, maintenance, and human-machine interaction scenarios. Real-time user feedback and iterative refinement is possible in the VR environment. Honda's Cave system is an example. It projects 3D cockpit visuals for visibility and ergonomics testing, replacing clay models and improving design accuracy by over 25%. Virtual reality, VR, enables early usability testing of complex or risky scenarios without physical prototypes. This helps detect interaction problems early, reducing costly late-stage redesigns. VR also allows medical device designers to simulate use cases and validate safety before manufacturing. This is especially important for high-risk applications where user safety is critical. VR supports motion tracking and presence maintenance, which are key for authentic human factors evaluation and biomechanical assessment of product interactions. This allows designers to thoroughly analyze the ergonomics and user experience of their products. Distributed teams can now collaborate in shared virtual reality, VR environments, overcoming geographical and disciplinary barriers. These VR spaces allow for the intimacy and effectiveness of face-to-face interaction. Even when team members are physically remote, immersive design reviews in VR reveal up to 3 times more design conflicts than traditional 2D reviews. Early VR-based conflict resolution reduces costly late-stage engineering errors by 25%. Automotive engineers were able to avoid 6 months of delays on a project through a 3-minute VR design review session. The ability to quickly identify and resolve issues in a shared VR workspace leads to significant time and cost savings. VR prototyping offers dramatic cost savings compared to traditional physical prototyping. Eliminates or delays expensive physical mock-ups, cutting development costs by up to 30%, reduces material waste significantly, while increasing iteration speed exponentially. Concurrent, iterative VR prototyping compresses new product development timelines. Changes that previously took weeks can now happen in just hours. Optimal strategy is a mixed approach. Use VR for spatial, ergonomic, and assembly validation, then reserve physical prototypes for material properties and final validation. Honda's Digital Innovation Lab is using XR/VR technology for visibility, operability, and assembly verification across their global development sites. This allows their design, engineering, and manufacturing teams to collaborate in shared virtual environments, identifying issues before building physical prototypes. The immersive VR approach enables early-stage quality checks that would traditionally require costly physical prototypes, catching errors months earlier. Using VR-based verification has reduced rework by 35%, improved quality scores, and accelerated time to market by over 20% across multiple vehicle programs. The slide outlines 3 key challenges to widespread VR adoption in industry. Infrastructure investment. The high costs of powerful computing, networking, and specialized VR equipment are a significant barrier organizational mindset. Cultural resistance and disruption to established workflows make companies reluctant to change skills development. Building internal expertise and coordinating cross-functional teams to leverage VR takes time and investment. However, the slide also highlights that successful companies like Keysight and Honda have overcome these challenges by aligning VR adoption with broader digital transformation goals. They treat VR as an enabler of cultural and operational change, not just a new tool. The key is to view VR strategically, invest in the necessary infrastructure and training, and drive organizational change to realize the full benefits. The future of VR in product development is an exciting and rapidly evolving field. Over the next few years, AI-driven virtual validation will become even more accurate and automated, with machine learning optimizing designs based on simulation results. In the 2026 to 2028 timeframe, integration with digital twins and real-time data will enable continuous product improvement after launch, closing the loop between field performance and design. Looking further ahead, VR will become standard for human-centered, collaborative and agile product development workflows across industries, fundamentally reshaping engineering practice. The convergence of VR, AI, IoT, and cloud computing is creating unprecedented capabilities for predictive design, automated optimization, and continuous innovation throughout product lifecycles. VR is transforming how we approach product development, breaking down silos and enabling more immersive, collaborative, and iterative workflows. This allows teams to work together seamlessly across disciplines and geographies, accelerating innovation. The benefits are measurable. Faster development cycles, reduced costs, improved ergonomics, and higher product quality. Leading industries like automotive and aerospace are already pioneering the use of VR. Setting new standards for innovation velocity and product excellence, VR is truly a game changer, unlocking unprecedented levels of collaboration and efficiency in product development. Evaluate your current product development processes to identify opportunities for VR integration. Look for bottlenecks, collaboration gaps, and areas where immersive validation could reduce risk. Invest in the right tools and cross-disciplinary training to build internal VR expertise and create champions. Make VR a core pillar of your product design and validation strategy to stay at the forefront of innovation. Companies that embrace VR today will define the product development standards of the future. The time to act is now. Don't get left behind as VR transforms the way we design and validate products.